Good morning, everybody. I'm just trying to see here. My connection doesn't seem great, so if there are some hiccups on your end, there's unfortunately nothing I can do right now, and I apologize, but I'm sure the backed up video will be free of such things. So let's see. Where are we? I had an empty page. Now I made another empty page. That's intelligence. Let's see. We got halfway, I believe. In one of these questions. Which one was it, though? I believe it was
You
number
got halfway through
5.
question 5.
Yes, number 5. Okay, good, good. Now, I don't have it in front of me, so we're going to have to do it again. Number 5. But that's okay. It's good practice. So, we said... Actually, no, that's not what we said. We had to find 2.72 repeating, and that is going to equal what kind of fraction? That's our issue. But instead of looking at that number, we're going to separate the whole number portion from the decimal portion and only worry about this guy. That's the only problematic part of this number. And that's going to make my life easier working through this method if I don't include the whole number portion. So I say let this 0.72 repeating, I can say it this way too, be represented, it's a little backwards, but still, by some symbol. Let's make it, I think we made it a star, right? Let's go with a star. We made it a star, let's be consistent, like that. Now behind the star is the fraction version of this, and I'm trying to figure out what that is. All right. So my star symbol equals 0.72 repeating. I'm always going to do the same, and that is multiplying by some power of 10, sufficient to get the repeated digits out in front of the decimal place, or saying it another way, move the decimal place enough times so that a repeated section so that it moves past the repeated section. In this case, I need to move it 2 times. So I'm going to multiply both sides by 100. I have to do both sides so that everything is still in balance. That gives me 100 of these star symbols and 72.72 repeating, because there are infinitely many 72s after. I just don't write them all. That's what the line is for. So now my next step is to get rid of the decimal tail, if you will. So I'm just going to take it away. The issue is that in order for everything to stay balanced, I need to take away the same thing, the same amount on either side. Now on the right, they're sort of speaking the decimal language, and they understand what I want to do when I want to take away 0.72. But on the left, I obviously have to do the same thing. Everything has to be in balance. But the left says we don't understand what you want us to do here. We don't speak our decimal language. We speak star language. So what would you want us to do? Then I go up here and see, oh, well, 0.72 repeating is exactly the same as a star. So I just have to rephrase my request by saying, take away a star, please. It's my job to make sure I take away the same thing on either side, but I need to speak the language of that side. Now that side can say, oh, okay, we understand what to do, and we'll have 99 stars left. And of course, on the other side, we have 72 left. Multiplication sentence. And so I have my division sentence that I pick so that the unknown symbol is alone on one side, and it'll be 72 divided by 99. And therefore, my fraction is, I could do it over here, 72 over 99. Now, of course, this is the method. Whoopsie, go there. Come on, 25. There we go. But I do get used to seeing fractions over 9, fractions over 99. As I do more of these, my experience does build, and it gets to a point where I feel like, oh, I knew that 0.72 repeating was 72 over 99. Sure, but it depends on your audience. If you have to explain it to someone that hasn't seen this enough times to notice those patterns, then it's not obvious. Why is it over 99? It makes no sense to me. I have a systematic, logical argument to explain with confidence, 100% certainty, that that is the corresponding fraction. So we have to go over here and say we actually have a mixed number, 2 and 72 over 99. So in part, it depends on your audience. You could do this with some examples and see, oh, well, if two of the digits repeat and there's nothing else fancy here, then the denominator is always 99. And if little Timmy is happy with enough of those examples, and he can uh, sort of do a educated guessing for a future one, if he doesn't quite want to do this lengthy argument. However, there are variations where my experience might be a little bit lacking and it's not as obvious. It all depends on where we come from, what we've done in the past. Then it doesn't become guessing anymore. It just becomes slightly modifying stuff I've seen before, but it requires that I've seen it before. Now, in a quiz, of course, I need to show my work anyway, so it doesn't really matter. But let's just continue this. Nothing I can do. That is just the joy of TELUS. Early in the morning, it happened yesterday as well. The backup video will be perfect, and if not, then I will redo everything in my own time. So I apologize if it's cutting out a lot. My only recommendation is either take the morning off and wait for the video that I'll put up later today, or try the 10:30 section. Maybe the internet is better then. There is unfortunately nothing I can do. I have a full bar, signal is strong. It's just one of those things. Same thing happened yesterday, but on my computer, and I upload that. So the backed up video that will be up later won't have any of the issues. Yeah, sometimes we're at the mercy of good old internet. So yeah, you can switch to YouTube, which is strange why one works and the other doesn't, but hey, we'll take it. Switch around, see what works. It's unfortunately nothing I can do. Okay, so we think we know what this is going to be, but I'm not 100% sure maybe because I've never done this before, or I need to show some work in the quiz anyway. So either way, I need to do this. What symbol shall we use? Let's go with smiley face. And that is, whoops, going to represent the decimal number in question. I don't have any whole number portion, so I don't need to isolate it. Then we're just going to write that with our equal sign. We are not really doing much. But now we have an equation, which is a mathematical sentence. Now I want to move the decimal place 3 times to get the repeating section out in front of it. So I'm going to multiply by 1,000. So I will have 1,000 smiley faces. And that's going to equal, I'm not going to start with a 0, right? 12.012 repeating. You can write the 0 there. I mean, it's just not something we do. But the 0, 1, 2 moved, and that is what repeats, not just the 1, 2. 0, 1, 2, 0, 1, 2, 0, 1, 2. Now, what I do is the same every time. I need to drop this decimal portion, which is 0.012 repeating. Now I could say here on the left as well, that's what I want, but they don't understand what I'm saying. The right side does. The right side says, okay, let's drop it. We have 12 left. The left side says we speak in smiley faces. We don't speak in decimals. It's my job to go and say, ooh, okay, up here. These two things are actually equivalent. The 0.012 repeating and the smiley face, they're the same thing, equal sign, same thing. So I'm just going to speak the right language for them to understand what I want to take away. I want to take away a smiley face. Oh, okay. Let's do it. We have 999 left. Multiplication sentence has an equivalent division sentence. I can pick, and it's going to be 12 divided by 999. Or that is in fraction form, of course, 12 over 999, which is exactly what we thought. But now we are 100% confident and we have the ability to convince someone else with a sound, logical argument and all those good things. So far, my mind isn't really blown. The patterns are exactly what I think they should be. I might just watch out for the 0. You can easily forget about the 0 being under the line and repeating as well. But so far, the denominator is 9, 99, 999, depending on how many digits repeat. So pretty straightforward stuff so far. Let us continue our examples and see if there is anything to see. Now I'm going to look at number 7. I'm not going to do number 7 right now. I am going to do number 7, but I don't want that to be the next one. I'll do number 8. No, I'll do not number 8 either. I'm not looking at them. I'll do, I don't know, 7a. Before I get to 7, I'm going to do this one, 0.00, no, just 0.0. 8, why not? But just the 8 is repeating. I thought I had one of these. I'll just insert it. Okay, that's what I want to know. What is this? In fraction form. Well, I'm doing the same thing. I'm going to pick a symbol. I'm not sure about this one. Let's go meh face. Not sure. Not quite smiley face, but I'll have a symbol to represent this decimal number. Then, of course, my symbol equals the decimal number. They are the same, just different versions of the same thing. I want to get the repeated portion out in front of the decimal point. So I'm going to have to move it twice, which means multiplying by 100. So I have 100 meh faces, and I have on the right 8.8 repeating. Only the 8 is repeating, right? Not the 0. Only the 8. So once I move the decimal point, there's a string of 8s waiting for me after it. Okay. So I want to do the same thing as before. I want to throw away the decimal tail, which is now 0.8 repeating. I have to move the decimal point of the top one once. Then they'll look the same. That means I have to multiply by 10. That means this guy is equivalent to, is what I need to subtract if I'm going to do the same thing on both sides. But it's still from this key up at the top. Then, no, I don't have. Man, I'm on fire today. I have 90 meh faces left. See, he's almost done. He has a little smile starting to form. He's almost done. Now, the next thing is to rewrite this to a division sentence. So meh face equals 8 divided by 90. Or, of course, my fraction is then 8 over 90. No, sure. I acknowledge that some of you are saying right now, I knew that. I knew it was over 90. Why do I have to do all this? Because not everyone is the same. You might be confident, but if you can't explain that to someone that is not confident, it's kind of useless. That knowledge is useless. Great for you, but not helpful to anyone else. I need a sound, logical argument. I'm not making this up. This is how we do it. Well, I made up the meh face, but that was my own flair. This is how we do it. A sound, logical argument that can now literally convince anyone. There is no doubt why it is 8 over 90. Now maybe there's a sticky point here. So let's do some more to be sure. So it's not always 999, 999. It really depends. So now we have to see how much does it depend and how much can it change. Now I'm not so sure anymore. Trust the method. The method doesn't change. The number can change. But the method, to me, is the comforting thing. I'm always going to start with the same thing. I'm always going to pick a symbol to represent my decimal number. I'm just writing out the equation that corresponds to that. Then I'm going to do a little decimal point shift. Then I'm going to take something away to get rid of the decimals that repeat. Then I'm going to write a corresponding division sentence, and I'm done. Those are always the same steps. Answer is I just go through the motions, one step at a time, and no single step as a too big a jump for me, logically. And I know by the end I'll have the answer. I have no doubt. I don't need to know the answer when I'm in step one. I don't worry about step three and four. I worry about that step and the next one. And one step at a time, I'll travel a long way. But I have to have faith, I guess, in the logic. That sounds weird. Okay, let's go maybe a 7B. Just making these up. I have 24 minutes to make up something. Let's go with 0.002 and only 2 repeats. Well, maybe this is not really feeling better for you. Maybe it's feeling worse. So let's make it a sad face. And let that represent my decimal number in question. Maybe eventually it'll get better, but right now you're feeling a little down. Or maybe the internet is still glitching, cutting out, and that makes you sad. It would make me sad. We have to pick a symbol. So, sad face equals my decimal number. I need to move the decimal point 1, 2, 3 to get it past the repeating section, which means I'm going to multiply by 1,000, which means I'm going to multiply by 1,000. I have to do the same thing. So we have 1,000 sad faces, and that equals 2.2 repeating. Now my goal is to get rid of the decimal tail. So I'm going to take that away. I see it. This is what I want to take away. I'm doing it. There it goes. The right-hand side says, all right, fine. 2's left. We're waiting for the left to catch up. No, I can't say the same thing on the left. I want to. But the left doesn't understand what I'm saying. The left speaks in sad faces. So I have to look at this at the top here and say, okay, well, how can I relate that? What I want to take away, how can I relate that to a sad face or a number of sad faces? See, the decimal point is right before the repeating section. Here it's a little far away. So let me move it twice, and then it'll look like this. Twice meaning times 100. So instead of saying I want to subtract this, I'm going to subtract 100 sad faces. That's the same. And so I have 900 sad faces left. Multiplication sentence turned into a division sentence. Sad faces equal, or sad face equals 2 divided by 900. No, 900. Obviously, 900. And my fraction is 2 over 900. I didn't know what the answer was. I do one step at a time, trust the process. Logically, it'll get me there with absolute confidence. But there's a good number of steps. What people do in general with this, not necessarily this specific question, but this kind of thinking, they worry about the answer. Oh, kids especially, they're obsessed with the final answer. That's all they care about. Nothing else matters. When for me, it is the last thing that matters. Yes, it matters, but not in my thought process, it doesn't. In my thought process, it doesn't exist. I don't give it any attention whatsoever. I know that if I follow the argument one step at a time, I could do 5 steps. I could do 10 steps. I'll get the answer. It doesn't matter what that answer is. It'll pop out when I'm done with my steps. Never do I care about what it is. But kids feel, and I've seen this, and I don't know how to fix it. Time. Time is the only answer. That if they don't know the answer right away, that means there's something wrong with them. They're stupid, I guess they think, or their brain just doesn't work like this, or whatever other lame excuse. That's automatically what they conclude. But it's unfair to do this many steps immediately in your head. The answer only comes at the end of those steps. Why would I start a journey by focusing on the destination? I need to take one step at a time and I will get there eventually. I'm not there yet. Don't obsess about it. But it's a hard lesson to learn. It's a hard lesson to learn. Time, experience, those things are extremely valuable. But for those things to do their job, I have to have patience. And that's something kids just don't have. Adults don't have that either. It's the most important thing. Patience. Trust the method we've come up with. We know it's right. It works every single time. It's right. So here I have the 1, 2 repeat and not the 0. Now what shall our symbol be? Let's go back to question mark in a box. That is going to represent the decimal number in question. Now make it clear what is under the line and what is not. If you do something like this, now how do I know what you're writing there? Is the 0 under the line? Is it not under the line? I can't tell. It's 50-50. So now I start to question whether you really understand how repeating decimals are represented. And if there's a question of your understanding, I have to subtract something. You have to convince me that you understand. And a part of that is to write everything correctly every time, because that is a part of this mathematical language. Precision in how you represent and say things. It's important. All right. So now, just my equation, of course, right? Full mathematical sentence. No. Is it Monday? Because I am writing all over the place. So, yeah. I need to move the decimal point so that the repeating digits are out. It'll obviously be 1, 2, 3. So I will multiply by 1,000, and I will do it here as well. We have 1,000 question marks in a box, then equaling 12 point, pause for dramatic effect, 1, 2, repeating. The 0 is never repeating. Okay, good. One step at a time. Do I care about the answer of the original decimal? No. I care about what I'm writing down right here, because if I obsess about something else, I lose focus about what I'm doing and I make a mistake. Here, focus on the here and now. What do I do right now? I drop the decimal, take it away. I see what it is, so I do it. I have to do it on both sides, I know, so that everything's in balance. The right side says, okay, we have 12 left. We're ready to go, waiting for the left. Left says, we don't know what to do. You're going to have to spell it out for us. We don't know. Okay, I will. but I have to do it. So I go here, I look, how can I rephrase it for the left side when they only understand question marks? I know what I want to do, but they don't seem to know. 0.12 repeating. It's very close to this guy. This guy has an extra 0. I can get rid of that by moving the decimal point once. Then they'll look the same. And if I move the decimal point once, that is the same as multiplying by 10. So what I want to subtract is equivalent to 10 question marks. Problem solved. They say, oh, okay, we have 990 question marks. Good. There's my multiplication sentence, and then I can have an equivalent division sentence as 12 divided by 990, or of course the fraction therefore is 12 over 990. So you get different kinds of people. You get different kinds of people, and I understand that I'm not like everyone else. But there is a way to think about these things that make your life easier. And it's just fact. Many people, if the majority of people, always look for shortcuts. Always look for a way to show off. Oh, I'll show him. I'm not going to do this. I'm going to look for a trick to figure out that it's over 990. Haha. I can't stop you. Well, I can stop you in a quiz because you need to show your work. But if that's the approach that you want to take in math, then let's see how far you get. It's just not how things are done. Understanding is always better. To the point where I don't even care about looking for patterns. It doesn't occupy any of my mental energy at all. I never thought, is this over 990? I literally don't care. I will just go through the motions of the steps that I've seen many times, that I trust, and the answer is going to come out to be whatever it is. I never care what the answer is. I care what the method is, what the steps are, and the answer will pop out as a result of that. In terms of success in mathematical and logical thinking, that mindset is way more effective. Don't obsess about the final answer. Focus on the thought process, and the final answer comes out of that as a result. It's a byproduct of your thought process. It's not the focus. It's just sort of a side effect that I get as a bonus. Then it doesn't uh, ever become an issue of filling in gaps and patterns and shortcuts. But it's always the same thing. I literally remember one thing, the steps, the recipe, regardless of what fraction you give, decimal you give me here. Some might be repeating, some might not, all kinds of things, all the variety. Nothing changes for me. The steps are always the same. But for those that look for shortcuts and patterns and things to show how clever they are by not having to write these 5 steps, it's all so different, so much in terms of variations and things. Well, if I see this, then it's that in the denominator. If I see this, then that, this and that. Oh, just so tiring. So tiring. I'll remember one set of steps and move on with my life. It's just so peaceful this way. Anyway. Now, number 8 looks a little easy for me. So let's change it. Let's change it. See what we can get. Now, we've covered everything. There isn't really much we could do to make it more difficult. In number 8, or we can just skip number 8. Have we done the actual 7? Oh, wow, I'm just not paying attention. Yes, we just did that. Wow. uh, it's pretty straightforward, isn't it? They're all straightforward once you understand the method. Let's quickly do it, I guess. I'm not going to do a 2 in my argument. I don't care about the whole number portion. So let question mark in a box represent my fraction, and then it's going to be an equation, of course, in the full mathematical language. So I'm going to multiply by 100. 100 question marks in a box will be 1, 2, 4.04 repeating. Drop the 0.04, 04 repeating. And if I look up here, that's exactly a question mark. So I will have 99 question marks. And that'll be just 4. And now, of course, I write all the detail. So there is no jump in any step. And that didn't even take a minute. I go up here. I see, oh, so it's 2 and 4/99. Piece of cake. Nothing to it. Nothing to it at all. It's just a matter of getting used to the procedure involved. And the answer pops out. I never worry about it. There's one side little note, really, just in case people are not quite familiar. I do want to just clear my conscience and talk about rounding. When it comes to rounding, I've asked people. Most of us, of course, have an idea to round a decimal number, right? Let's say, for example, oops, uh, let's do exercise 14. 14, and we round 146.08. Ooh, that's an ugly 8. I'm sorry. To the nearest 10th. Most have an idea of what we're doing here. But what is rounding really trying to do? I've asked that to a couple of people. What are we really doing? What's the point? No, they have no idea. They can do it like a little monkey. Look at this, do that, shortcut, 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 but they have no understanding of what we're doing. When it comes to rounding, we have this number, whatever the number is. We're really asking which one is it closest to when where I have to stop at the 10th digit. Now, what are my options? Well, on the high side, it's 146 point nearest 10th, right? Oh, nearest 10th. Yeah, 0.1. That's the 10th digit. I can't write any more. That's my rule. Someone decided that. That's on the high side, right? That's above this one. Or on the low side, it's 146.0. So this number that I have sits between these two. When I round, I'm really saying which one is it closest to? Is it closest to the low one or closest to the high one? So what I have to do is look for the gap. Now, if I want to see another digit here, the 100th digit is 0. So I do look at the one right next to the digit that I stop at. I stop at the 10th, so I'm going to look at the one right next to it. The line is where I stop. The box is the one I'm looking at. Because it's an 8, I have only a 2 gap to the top one, the top option. But I have an 8 gap to the bottom option. So I'm closest to the top one, and that's going to be my rounded answer, we say. That's going to be the one of the two that is closest to my actual number because the gap is the smallest. If, for example, I can have many options here for this one to be the closest still. 9 would work. 6 would work because the gap to this one is 4. The other one is 6. So obviously the closest one is the high one. But now at some point we sort of were stuck in the middle. So everyone had to agree that if it's a 5, then we're stuck perfectly in the middle. But we have to pick one. We're always going to pick the high one when it's a 5. Everyone agrees. Yes, there's a meeting. Okay, let's move on. But when it's lower than 5, then we're going to go the other way because then the gap is obviously less for the small one. So when we round, we really are asking if we're limiting how many digits we can write, which one of the options is now the best. Okay, so number 2. And it's one of those things that you can teach little Timmy. Well, I'm not going to use the word teach. You can tell little Timmy what to do, where to look, how to decide which one to pick, and that's rounding. But he has no number sense. He has no understanding of what the point of any of this is. He just does it because he doesn't want to get into trouble with his teacher, so he just does it. They're very complacent. But that's not the point. We should build some sort of understanding and brain development and something good. Something good. It's not just about getting him to the next grade. We want to actually develop some sort of brain matter, thinking skills, an understanding of numbers. And those little things, that little bit of understanding transfers to many things. Many things. So now I want to round to the nearest hundredth. So my option is cutting it off right there. I can't necessarily just cut it off. Those are the digits I'm allowed to write. So on the high side is 4.59. On the low side is 4.50. No, sorry, that's not it. 7. I am thinking of too many things at the same time. Still not true. It's an 8. It's obviously Monday today. I'm thinking of the next example, and instead of focusing on this one, I'm doing exactly what I say I shouldn't do. Yeah, exactly. So, do you look at the next digit and say, well, I'm trying to stop at the 100th digit. The gap, if I put some zeros there, is 5 or up. Then I go to the bigger option. 4 or down, I'm going to go to the smaller option. Let's see if there's one that actually round down. None of them. I'm going to do a 3A, 9, 6. And I'm going to round to the nearest unit or 1, one's position. So what are my options here? Well, on the low side, it's going to be 702. On the high side, it's going to be 703. Those are the numbers surrounding my number. So I look at the next digit after where my cutoff will occur. It's a 3, which means the gap is less to the smaller one. 4 or less, and I'm going to go down to the smaller of the options. Now I don't care too much about number 4. It's extremely rare to the point where I can't even remember seeing rounding to uh, places deeper in to the left of the decimal point. That's not common at all. We round to small digits after the decimal point. So I wouldn't really do number 4. It's just confusing to little Timmy when it's not common. We round little bits off. I don't want to throw ones and tens and stuff away. But it's important to understand, what is rounding trying to do? Now, for some reason, it's just more presentable in some cases to not have too many decimal digits showing. I might have them, but for presentation purposes, it's not necessary to show them all. Rounding is just helpful for presentation. And then the question is, I want to pick the rounded option that is the best representation of my actual number. I need to pick the closest one. And I base that on the digit that is after the one I'm rounding to. Understanding always beats memorization. Always. It's a fact. It's just, what kind of teacher do I want to be? What kind of person do I want to be? Everyone's different. It's up to you. All right, I believe that wraps up our chapter. It's very exciting. We're almost at the end. Well, sort of chapter. The chapter on fractions and decimals, sort of. Tomorrow, we'll see what I want to do. There's some little things that might be interesting. Uh, I'll see what I want to do tomorrow. So we're technically not done with the chapter. There are some other little things to mention, but the main part in terms of quiz questions, that is certainly done. All right. We'll continue the discussion tomorrow with some little extra things before we officially wrap up the chapter. Are there any questions at this stage? All right, then we will see each other tomorrow. Until then.